This movie is for Learning Target 1 in Unit 8, Pythagorean Theorem and its Converse. We're going to skip the warm-up. Our essential understanding: if you know the lengths of any two sides of a right triangle, you can find the length of the third by using the Pythagorean Theorem. We've used this theorem quite a bit in geometry, coordinate geometry, when we want to find a distance between 2 points. And so pause this movie and add Pythagorean Theorem to your purple sheets, and then press play when you're finished. I would strongly suggest in this lesson, when you add to the purple sheet, writing down the visuals that you get, the if-then. These can get kind of long and sometimes wordy in this unit, so you may just want to focus on the if-then visuals. So press play when you're finished adding this to your purple sheet. A Pythagorean triple is a set of non-zero whole numbers a, b, and c that satisfy a squared plus b squared equals c squared. Notice none of these are decimal numbers, 3, 4, 5, and what we're looking at is 3 squared plus 4 squared equal to 5 squared. Now, the reason why I want to set it equal to 5 squared is because 5 is our largest value here, so it must represent the hypotenuse. So I'm looking at 3 squared plus 4 squared, 9 plus 16, and that equals 25, which is 5 squared. So here's another Pythagorean triple, 5, 12, 13. 13 would have to be my hypotenuse because it's the longest side. And I can see that 5 squared plus 12 squared does equal 13 squared. We have an 8, 15, 17. 17 would have to be the hypotenuse. And does 8 squared plus 15 squared equal 17 squared? It does. That's what makes each of these Pythagorean triple, 7, 24, 25. But not just any three numbers will make a Pythagorean triple. So keep that in mind. These are just some special ones because they're all whole numbers, none of them are decimals, and it works in the Pythagorean theorem. Let's practice the theorem. What is the value of x? And then simplest radical form, it's okay if you don't know how to do that, but let's solve for x. I can see here that 20 is my hypotenuse. I know that because it's opposite the right angle. So I can set it up as 8 squared plus x squared equals 20 squared. I'm going to solve this. 8 squared is 64, 20 squared is 400. Subtract 64, and then take the square root of both sides. So my exact answer is 336. If you want to figure out how to put simplest radical form, 336, I'm thinking of the different factors. I know 16 times 21 equals 336, and this is a good one because I know what the square root of 16 is. The square root of 16 is 4, so this would give me 4 square root of 21. That's if you want to learn simplest radical form. Now you could leave it as a decimal or as your exact answer, square root of 336. Pause the movie, try this on your own. You're going to be asked at the end of the movie to put in your answer for both A and B. The hypotenuse of a right triangle has length 12. One leg has 6. What is the length of the other leg? When in doubt, draw it out. So let's first draw out the situation. 6, x, and 12. 12 is my hypotenuse because it's the longest side. It's opposite the 90-degree angle. So I plug it in. I'm solving for x, so I'm going to subtract 36, take the square root. So I get square root of 108. If you're doing simplest radical form, you can see 108 factors down into the prime factorization 2 times 2 times 3 times 3 times 3. Takes 2, it takes, oh, interesting, didn't mean to do that. It takes 2 of our factors to come out as 1. Ooh. So that's why a 2 comes out here and a 3 does. 2 times 3 is 6, so I get 6 square root of 3. It is perfectly fine if you leave it as square root of 108. We're going to skip this one, and I would like you to add the converse of the Pythagorean theorem. We've looked at if we have a right triangle, then a squared plus b squared equals c squared. The converse says if a squared plus b squared equals c squared, then we know we have a right triangle. So pause the movie, add this to your purple sheet, press play when you're finished. So a triangle has lengths 16, 48, and 50. Is the triangle a right triangle? Well, if in 1648/50, I know 50 would have to be my hypotenuse. So what I'm going to do here is I'm going to set up 1648/50 into the Pythagorean theorem. 16 squared plus 48 squared equals 50 squared. And I see that I get 2,560 equal to 2,500. That's a false statement. So we cannot have a right triangle. Once you know each length represented by the hypotenuse, does it matter which length you substitute for A and which one you put in for B? The answer to that is no, because it's commutative. Addition is commutative. So what we've got here, we know in this previous one that this is not equal. In fact, the hypotenuse squared is less than A squared plus B squared. So what we could tell is if it is obtuse, where C squared is greater than A squared plus B squared, so it's not a right triangle, it's actually obtuse, or that it's acute, where C squared is less than A squared plus B squared. So on this slide, I think I would add the if-then visuals to my purple sheet because the wording here gets kind of crazy. So pause the movie, add that to your purple sheets, and press play when you're finished. So you can see here, if C squared is greater than A squared plus B squared, I've got an obtuse triangle because I've elongated the C length. And if C squared is less than A squared plus B squared, I've actually minimized it, and I've got an acute triangle. So a triangle has a length 6, 11, 14. Is it acute, obtuse, or right? So which one would we select to be the hypotenuse if we were testing this out? It would have to be 14 because that's the longest side. So what I'm going to do in my C squared compared to A squared plus B squared is I'm going to plug in 14 for C, 6 and 11 for A and B. I'm going to simplify these guys. 14 squared is 196, 6 squared is 36, and 11 squared is 121. And I see that 196 is greater than 157. That tells me that my C squared is greater than the sum of my legs squared. And because of that, it must be an obtuse triangle. Because if it were equal, it would be a right triangle. But C squared is greater than A squared plus B squared, so it's obtuse. Try number 5 on your own and then press play when you're finished. This will be answered at the end of the movie. Now that you've answered all the questions, that's the end of the movie. Put in your answers to those 2 questions now on It's Learning.